Gear up and get ready. You're watching Engineering Talk, where we turn what if into how to. Let's dive in.
Welcome to Highway Engineering. Let's explore pavement designs. This is where we build the future of transportation.
All right, think about this for a second. You're driving down the highway, maybe on a long road trip, and you notice something you've probably seen 1,000 times. Some roads are black, and some are, well, they're gray. Ever stop and wonder why? It seems so simple, but believe me, there's a whole world of incredible engineering hiding right under your wheels. Yeah, you know exactly what I'm talking about. On one hand, you've got that classic black asphalt, and on the other, that light gray concrete. So, what's the deal? Why do we have these two totally different types of roads? That's exactly what we're going to get into. So, to really get to the bottom of it, we need to start with the basics. What is the thing we're driving on every day? Let's peel back the layers on this surface we almost never think about. Okay, so the official engineering term for this is pavement. But here's the most important part of that definition. It's a layered structure. This is so key. A road isn't just, a big slab of stuff they pour on the ground. No way. It's actually a super complex system engineered from the soil all the way up. And every single one of these pavements has some really critical jobs to do. First, it's got to be strong enough to handle all that traffic. We're talking cars, huge trucks, the whole shebang. It also has to spread out the weight of those vehicles so it doesn't wreck the soil underneath. And of course, it needs to give us a nice, smooth ride while protecting that soil from rain and snow. So how do engineers pull all that off? Well, this is where we meet our two contenders, the two main players in the world of road design. All right, let's put some names to these faces. The black roads, that's what we call flexible pavement. You probably know it as asphalt or maybe blacktop. And the gray ones, those are rigid pavement, which is just good old cement concrete. But those names, flexible and rigid, they tell you everything you need to know. And I mean it, because the difference here is way more than just the color. We're talking about two completely different philosophies of how to build something strong. And for engineers, choosing between them is a huge decision. It's a big trade-off, They have to think about everything, the cost, the climate, the traffic, and just how long they need that road to last. So let's start with flexible pavement. The name really gives the game away, right? It's designed to bend or flex just a little bit when a car drives over it. Here's a great way to think about it. Imagine you put a big stack of magazines on a really soft bed. If there's a dip or a lump in the mattress, the magazines are going to bend and follow that shape. That's kind of how flexible pavement works. And this is what that looks like on the inside. The weight from a tire doesn't just push straight down. Instead, it gets transferred from one tiny piece of rock to the next, spreading out in a cone shape as it goes deeper and deeper into the road's layers. It's all about that grain-to-grain transfer of pressure. Okay, now for the total opposite, rigid pavement. As you can probably guess, this stuff does not flex at all. Let's go back to that mattress analogy. This time, instead of magazines, imagine laying a big, thick sheet of plywood on the bed. That board is so stiff it won't bend into the dips. It just bridges right over them, spreading your weight out across a much, much wider area. And that's the whole philosophy right there, because it's so incredibly stiff, so rigid. Any little imperfections in the soil way down below don't really affect the surface you're driving on. All its strength comes from what engineers call slab action. The whole thing acts like one giant, super strong plate. All right, so we've got the why. Now let's get into the how. How are these things actually built? Because the real secret, the magic behind both of these designs is hidden in their layers. Let's dig in and see what's going on underneath. And here you can see the two philosophies in one picture. It's pretty clear, right? On the left, you've got the flexible pavement, which is this deep stack of a whole bunch of different layers. Each one has a very specific job to do. Then on the right, you see the rigid pavement. It looks way simpler, doesn't it? It's really dominated by that one massive, thick slab of concrete sitting on top of a base layer. So let's quickly build a flexible road from the ground up. First, you start with the soil itself. That's the subgrade. Then you put down a subbase, which helps with drainage and support. On top of that goes the base course, which is the main strength layer. Then you've got the binder course, which is the thickest asphalt layer. And finally, you have the surface course, the smooth part our tires actually roll on. But believe it or not, we're still not done. To make sure all those layers work together perfectly, engineers add a few more super thin but absolutely critical coatings. First up is something called a prime coat. This is a really thin liquid that soaks into that grainy base layer and basically plugs up all the little holes. Then they spray on a tack coat. This stuff is exactly what it sounds like. It's super sticky, almost like a glue, and its whole job is to make sure the different layers of asphalt bond together and don't slide around. And finally, you might get a seal coat. This is a thin layer on the very top that acts like a raincoat for the whole road, keeping water out, and it also gives your tires that extra bit of grip you need to stay safe. Okay, so what does all this mean? What's the big takeaway from all this incredible hidden engineering that's happening right underneath us? So let's wrap this up. Here's what you got to remember. Our roads are either flexible, that's the black asphalt, or rigid, the gray concrete. Flexible roads work by passing the load down through a bunch of layers. That's the green-to-green transfer. Rigid roads, on the other hand, use the brute strength of one massive slab action, to spread the load out. Both are just amazing feats of engineering, designed to handle an incredible amount of stress every single day. So next time you're out for a drive, you'll know the story of the road you're on. And really, it just makes you think, right? What other amazing pieces of everyday engineering are just hiding in plain sight all around us?
Thanks for watching Engineering Talk. If you enjoyed this video, don't forget to like, subscribe, and keep learning. See you in the next engineering discussion.